Yeah, welcome back to the channel. Hope everybody's doing well. And in today's video we are taking a look at the UT196 multimeter from Uni-T. This is a 6000 count true RMS professional multimeter aimed at the solar market. Has capability to read up to 1700 volts DC and 1500 volts AC. Now it is a very basic package. Pretty much what you see in front of you is what you get. Everything comes in this little cardboard box here at the back. You get a little meter case with it. Again, very simple affair, just with the partition inside it, a couple of straps to hold the meter in, another couple of straps to hold the leads in. You get an instruction manual and a little certificate of conformity card there, something like that. As you can see, it's all in Chinese because of the way I purchased the instrument. The manual itself is also in Chinese. You can download an English version from the website, so it's not too much of an issue there, but it's a pretty well written manual in English. It's got all the right information in there that you need, specifications and basic measurements to make with the instrument. That's that over there. The instrument itself, you see in front of you, it comes with a set of test leads. Interestingly enough, these are 5000 volt leads. I'll see if I can get a close-up, because I doubt you'll be able to see from there. The lead is made from Hurwell. Feels as though it could be silicon, but it's not the nicest of feeling of silicon that I've found, so I'll probably stick these across Mega and see what leakage I can get off them. The probes themselves are fairly thin and slender. You do have GS38 caps on the front of them. That gives a rating of Cat 3, I think. So we've got a Cat 4 rating of 1000 volts on these leads here. Whilst the caps are fairly slimline, they don't go in all of the terminals. If we switch them over to ohms here, so you can see we've got the reading there of a couple of mega ohms. If I try to go into the SAK4s, you can just about get the reading there, but I can't get going into smaller terminals there. If I go into the sender partition, then I can get a reading on there. It says as long as I get it in the right place. It's a bit difficult to make contact. Yeah, there you go. So you do get the reading there in that respect. You can remove these caps. Obviously you've got a much slender tip there, but you lose the GS38 protection, and then we can go into the terminals, no problem whatsoever there, and into the other one there. So yeah, they're not too bad leads. Could just do with a slightly slimmer cap on there to aid getting into the terminals, or the ones that I'm used to anyway. Leads plug in, the jack's quite nice. Got a good long shroud on them and fits snugly into the actual connectors there. So for the instrument itself, it's Uni-T's new kind of ruggedized look that you've got for the instrument. The red rubberized kind of hard plastic more really is moulded direct onto the case. You can't remove that. It does provide protection for the screen. You can see the raised areas around here, so if you drop the instrument you've got fairly good protection for the screen there. Standard rotary control at the front here for selecting your measurement function, backed up with some of these other functions on the push buttons here. Select mostly to go between AC and DC, but also your ohms, capacitance and diode. Over there, a range, so you can manually drive the ranges. Low pass filter for the AC function, min-max and relative mode there. Torch at the back, peak function, and a hold function and backlight as well when you hold it in. At the front here, I said we've already got 2 jacks here, which is where the majority of the measurements are made, from these 2 jacks. Over this side we've got the input jacks for the clamp function, which you can only measure current through a clamp function, and it's only AC current as well you can measure on this, and you have to put the jacks into this one here. Around the back you do have the little holders for your leads if you want to, or if you want to go single probe mode, and you can put them in there. So they've got holders there on the back. You do have a little clip here that you can swing round to hang off of a nail or bolt or something like that, and you do have the torch at the back here as well. Battery compartment, underneath the tilt stand. 1, 2, 3, 4, 5 screws to actually open this up, so quite a lot of screws to get into your battery compartment. And then you have the Intertek and UKCA independent verification there, embossed on the back. The only other thing I will say is this tilt bar, whilst it works okay, no problems, quite sturdy, it doesn't seem to close properly on my instrument. And you see it's closed down there, but when I hold it up it flops open. So no real big deal. Just all the other instruments that I've had, the tilt bar tends to lock in the closed position, if you will. First time I've seen one that moves around like that. Okay, so looking at the actual functionality of the meter itself, you can go to the first position, which is DC volts. So we'll put the results up for the DC voltage measurements. They've been made on the millivolt scale here and on the main DC voltage scale. Tolerance on this scale is 0.5% plus 5 digits. On the main scale it's 0.2% plus 5 digits again, and all readings are within spec, as you can see on the table. And for the DC millivolt function, 539, 540 going in, 540 being measured on the UT196 there, no problems whatsoever. And at the other end of the scale, there's our 90% of the 1700 volts at 1532.31. It should be 1530 going into it at this moment in time. AC volts, again, we can run from 0.1 millivolts using the millivolt function over here, and then up to 1500 volts at 0.8% plus 3 digits. You also have the low pass filter that you can put on for this one. But we go up to 2% plus 9 digits from that one. So on with some AC voltage measurements. Currently measuring 540.1 and we are 540.7.8 on the UT196. I'll put the table up again and you can see that all the results for this are totally within tolerance. We also have LPF mode on this, which is a press of this button here. You see we're in LPF mode, and the accuracy in LPF mode goes to 2% plus 9 digits. And what we also have here is AC/DC mode. We can flip over to there, and again we can see we are reading 539.8 this time, with 540 going in. So all the AC readings seem to be totally within tolerance. Nice set of results there. And we then have the ohms, capacitance, continuity and diode function. Defaults to the continuity function, and then we can go through these. There's the ohms, which is 0.1 ohm to 60 mega ohms at 0.8% plus 2 digits. And you can go to capacitance, which is 0.01 nanofarads to 60 millifarads, so quite a range on that. 1.9% plus 5 digits. And then we go to the diode function. So just going to diode function there, and you can see we're actually reading 3.061 volts output on the diode function, so this should be pretty good. We'll take the meter out of the way. So we'll have a look and see how we get on with the actual diode tests. We don't get any crop clip leads with these, which is a little bit annoying. And quite surprising given that it can measure up to 1700 volts, but we'll see we go there. So we can see we've got the red LED lit there, green just about lights, the white one does about light, the blue one, sorry, it's lit, and then the white one is lit, no problems whatsoever. Interesting, when you go to the short you do get the beep. When you're on the diode test you get the short. So we move on to our other diode board here. We've got our power diode at the front here. Go on to him, standard reading 0.5 volts. This one's reverse polarity, so you see we don't get a reading that way, but if we go the other way we should get a reading. 0.5 again, all good. Again you can hear the beep. What have we got on here? We've got a Xeno diode here, which is all okay, 0.7 volts. We've got our Schottky diode, should be lower, 0.19 volts there, all good. And then we've just got a standard diode again, 1.1 volts on that one, and then we've got a little amber LED which lights up, and we get a 1.7 volts, so no problems with any of those measurements there. For the diode functionality, continuity we did here. Let's just change them back to our continuity function. So not the fastest, but fairly good. So I'll just swap over to a set of probe master leads and see if that improves on the continuity function. Yeah, you can see there is an improvement using the probe master leads, interestingly enough. So Uni-T, I guess, aren't famed for their leads, are they? So yeah, but they're good enough for an electrician, really. We don't usually need that faster continuity function. I also didn't mention as well, it is purely sound on this. You're not getting any, well, we do have a little light up there, that doesn't light up on the continuity mode. Okay, so we're looking at the resistance function here. Again, we'll put the table up for the measurements on this one. 6 ranges, varying different tolerances across the ranges there. We made a 90% reading on each of the ranges, which is all within the scope of this decade box here, so they've all been made. I guess worst one at the top end of the range you see here, 53.89 we're currently reading. 54 mega ohm input going in, which is minus 0.2%, so no real problems there with those measurements. As you can see, all the other measurements are also within specification. So moving on to the capacitance function, I'll put the table up again for this one. Again, 90% measurements made for all the ranges apart from the 60 millifarad range on this one. I can't get anywhere near 54 millifarads for a capacitor. The highest I've got is a 4.7 millifarad individual capacitor. So what I've done, along with components like that and the decade box, I've made little capacitance bridges up here to put in parallel to bring the capacitance up, and made the measurements that way verified against my other instruments. And you can see here that there are no problems. We are all 0.593% is the worst one for the 6 millifarad, which is 5.4 millifarads. But you can see on the capacitance box here we're putting in 5.4 microfarads and we're reading 5.407 on the screen, so that is all good. And then we move around to the clamp function, which you've got 3 manually selected ranges on this. So we have a 100 millivolts per amp range there. We can go to the ranges 10 millivolts per amp and then a 1 millivolt per amp. So this will get you from 0.01 amps up to 3000 amps, plus or minus 0.8% plus 8 digits. But obviously that will be also dependent upon whichever current clamp you plug into this to use as well. And as I said before, it's AC only. The only other interesting thing with regard to this range is that the peak function doesn't work. I would expect peak function to work, but it doesn't. See, it just clicks off. Peak function actually works on AC volts only. Hit there, and then you can see it's moved to peak, and you can go through peak min, peak max, and hold it in to get back out of it. So slightly strange quirk with it there. So that's your AC current measurement. So this is the maximum I can get up to with my current setup. I'm using the Fluke i2000, which can measure up to 2000 amps. I'm going to inject 20 amps through the 100 turn coil, and that should give me 2000 amps on the Uni-T here. So I'll inject that there, and you can see we've got 2013 amps, and we'll read the frequency at the top there as well, 49.99 Hertz, 2014 amps now. So that is all good and within spec. The other thing to be aware of with the UT196 is that the current measurement is a voltage application. So where you have current clamps such as this one from Chavananu, there's a 200 amp to 0.2 amps, obviously all AC, but it's given out, it's a proper current clamp and not a current adapter. This one will not work with the UT196. You need current adapter that will put out a millivolt signal, not a current signal. And then finally you can move to NCV, non-contact voltage. the very last function there. So I'll just give a little demo of the NCV mode. It doesn't appear to be that sensitive. We've got a main socket here, extension lead socket here. If we hold it across the top here, we can see it starts to beep away. There's no change in the screen whatsoever. You do get the little flashing light at the top there. If I turn this through 90, you can see it actually turns off. Turns back on again if we go away. So what's that, 1/4 inch gap, I guess, there at the top. Go across the top, trying to pick the bars inside the socket. Doesn't really seem to like it. Turn it the other way. Doesn't like it at all on the back there. So yeah, not the most sensitive. As I say, you just see the light there. You don't see any change in the screen. A lot of them have bars nowadays that you can see the number of bars that come up to show how close you are to the source. So it seems a little bit limited. So yeah, that one's not doing it for me really. Okay, so we've set our insulation tester up to have a look at the leakage on the leads. We are going to inject 2.2 kV to start with, because that is the equivalent peak voltage for a 1500 volt AC voltage. We'll press the go button there. And you can see we're at 2.25 kV and we are 117. If we grip the leads a bit, well, they do drop, don't they? So we're still in the gig ohms, 6.5, squeezing quite hard now. That's interesting, 3.4, 3.39. Yeah, I mean, you'd never put that much pressure on leads when you were using them, so but they are dropping quite considerably. If we let it go again, you can see it rises up. So yeah, if you get the leads trapped, not such a good idea, is it? We'll just stop that. 13.7 gigaohms. Let's wind him up to 5 kV max, because they are rated at 5 kV. So we'll see what happens. 29, 27 gigaohms, so we were in the 100 gigaohms initially when there's no pressure on them. Put light pressure on them. It's to start to drop again. Squeeze them. And then we get down to 2 gigs. Yeah. Yeah, I mean, obviously bearing in mind as well that they are actually pretty much brand new at the moment, clean. No damage to them or anything, so yeah, there's probably better test leads out there in terms of insulation than these ones, which is surprising given the rating that they've got on them and what their intended use is for, their intended working voltage. So there you have it, that's the UT196 Solar Pro professional multimeter from Uni-T. It's available in the UK from the likes of eBay and Amazon, and you can get it from AliExpress as well. Retails for around about £130 to £150 depending on where you get it from. Pretty nice multimeter, a very rugged design. Does have a good set of ranges on it, although I do notice as I've been testing this that it doesn't have a temperature range, whether that matters to you or not. All the measurements I've made with it have been accurate. Got a nice large screen there, good buzzer on it, good backlight on it. I'll just turn the light off and show you the backlight a bit better. So there you can see the backlight there. It's pretty good. It stays on for quite a long time, so quite happy with that. In contrast, the actual torch on the back is perhaps not quite so good. I'm not sure how well it'll display that up. I mean, it's okay, but it's fairly mediocre. You can see it is on the back there, so for me it's kind of in the wrong place. I would rather have seen it up here, so that if you are probing with the instrument, then you would be lighting up what you're actually working on, whereas it just sat down there on the bench. You'd have to be kind of probing behind it, wouldn't it, to see what you've lit up, so not much use as a torch for use with the instrument. It's more on its own really to light a few things up. Obviously we had a bit of an issue with the NCV function as well, which was a little bit awkward to use, and also the peak function there. Rather strange that it only operates in the AC volts. Couldn't get it to operate on the AC current at all. And just check whether actually, no, it doesn't work on DC volts either. It's purely that, yeah, strange. Yeah, very, very strange that they could do with looking at really and changing it so that it does work, at least with the current. Leads, fairly mediocre with it, but they're quite usable. Would have liked to have seen a set of crock clips with the leads, especially with the kinds of voltages you can measure up to with this instrument. But yeah, all in all, fairly average sort of instrument. I think it would do the job for you at the end of the day. But that'll be the end of this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next one.